So we've generated, Dr. Goller and Dr. Stefanie Chen and I at NC State University in the biotech program have come up with this really great case study that's very timely and appropriate for students in introductory biology or genetics courses. And it really helps students utilize these free bioinformatic tools available online, and that is NCBI BLAST as well as NextStrain. And the case revolves around students being investigators as part of the CDC. They're virologists, and their job is to track where patients might have become infected with COVID-19. And it begins with 2 patients presenting in Washington, DC, and investigators need to use sequence information to figure out where the origin was of these viral strains. And the first thing they need to do is actually examine the viral strains or the DNA sequences by going online using NCBI BLAST and looking at the conserved regions of SARS-CoV-2 from the original patient 0 in Wuhan, China.
Well, this sounds like it's perfect for students right now, and it is going to provide some really good information about some of the new career possibilities coming out of this pandemic. So tell me more about what students would actually engage with.
Sure, so I'm going to talk a little bit about the BLAST tool, and let me go ahead and get my screen share going here. Share. All right, so do you guys see the NCBI site now? Great, thank you. So the first thing, as Dr. Srougi mentioned, is they want to pull up the genome for, this is kind of the consensus genome of the coronavirus. So they just go to the NCBI website, and under genome, they want to search for the full name, so severe acute respiratory syndrome coronavirus 2. And there will just be one result for that. And then from there, they can use this reference number, the RefSeq, and then go and use the BLAST tool. So this is also an NCBI tool. You can see here, this is the BLAST page. And then one interesting thing here that they'll do, and the next step is this, they now have this new search beta coronavirus database. And so that's gonna return hits that are specifically for the SARS-CoV-2. Originally, we just want them to see sort of other things that might be related to. And so we're just going to go to the nucleotide BLAST. And just the first box is where you would put that RefSeq number that we got on the first page. And then we also ask that you change the algorithm parameters down here. Change this box to 500 to give slightly less related things so we can see other things it's related to. If they forget to do that, it's fine. It'll just, all of the results will be SARS-CoV-2. And that's actually pretty much what we're getting here. So really important thing about this activity is that as more and more things go on the database, the results will be different. So in the key, we've provided some results and the date that we got those results, but they will be changing. And so they won't exactly match. And so that's kind of the fun part as well. So we see some of the top hits are from Wuhan, China, but all of these have the same max score. So if they have the same max score, they're actually returned sort of randomly. So in France and Wuhan, China are the top hits. And then you can just kind of go down here. And actually at this point, as of May 20th, the bat coronavirus is no longer coming up as a result in this page. So they might not get any non-human viruses, and that's just because it's limited to how many results show up on this page. In the second part, they're going to go through that. So we just go back here. They're going to use that specific beta coronavirus tool, and they're going to use those 2 patient sequences that we provided. And those are real mutations of the coronavirus that we got off of the NextStrain that my colleague Dr. Goller will briefly discuss. And then the idea here is they will all be SARS coronavirus, but we're looking at the location where those are from. So in addition to the information that comes up on the main list when you go through the BLAST, you can also click over here on the accession, and that will tell you who submitted it and where it's from. So this is from San Francisco. So not just the United States, but also specifically San Francisco. So that can give you a little bit more information about where that point was. And you can do this for each of the top hits there to get a better idea of location. And we tied this into the next strain. So I'm gonna pass it over to my colleague, Dr. Goller, to talk a little bit about how that ties in.
Perfect. So the next part of this case, we talk about phylogenetic trees, and we use a really fun and interactive web-based tool, which is NextStrain. So this web-based platform allows us to visualize phylogenetic trees and public health data that has been contributed almost in real time. And it's a very interactive website, and there's a section now for global COVID-19, so SARS coronavirus updates and sequences. So as you can see, you can hover over different parts of this phylogenetic tree and obtain information on the number of mutations, the divergence. You can zoom into different clades. And you can also see information on the geographic location of these samples. So what we do in this activity, in this part of the case study, we have students investigate the data deposited in NextStrain by looking at several tree options, looking, for instance, at branch length as both time and divergence, looking at a clock layout. And if you scroll over here on the right of my screen, you'll see that there's a map that's interactive and provides a video that simulates the data that's provided here on the left, the phylogenetic tree. Another great element that NextStrain has is they have really extensive documentation on how to use this web-based platform that students have access to if they have a browser. It doesn't require any downloads. And they have a nice short tutorial that takes about 2-3 minutes to read, but it's how to interpret phylogenetic trees, and it ties into how NextStrain reports and visualizes data. So it provides some information on reading a basic phylogenetic tree, as well as the data that NextStrain reports. So with that, I'll stop sharing my screen. And the third part of the case wraps up by doing another blast, right, Dr. Chen?
Right, so that would be the beta coronavirus blast section. But actually, the very end is coming back to the virologist case and talking about what does this mean as far as where these two individuals from Washington, D.C. might have come from and what policies we can put into place to prevent that in the future.
And it's got a nice ethics component too, where students can really reflect on what their decision-making policy is and how that may affect different populations and individuals differently, and some things that they need to consider when thinking of global policies.
Have you had the opportunity to use this online or primarily in person so far?
Not yet, but it's likely going to be a case we will use, or at least I may use in a course offered in the fall.
And I will also use it in a freshman class in the fall.
Yes.
And I was wondering, how long does it take? Like, how long would you put aside for this? Would you do this over the course of a week, or would you do it in one session?
I think the nice thing about this case is, depending on what your course structure is, it's really easily changeable, but it was designed to take place in about a 50-minute class session. But the case also has options in the teacher notes that instructors can look at if they wanted to extend that time, or good places where they might want to break it up or give students outside of class homework. So potentially you could stretch it as far as a week, or just have it implemented in one about 50-minute class session. So it's flexible in that way.
Excellent. All right. Thank you very much.
Thank you.